Assalamu alaikum wa rahmatullahi wa barakatuh. In this video, we are going to study part 3 of Kinematics 1. At the end of this video, you will be able to determine the characteristics of the displacement vector and determine the characteristics of the average velocity. But before, let's remember the main ideas of the previous part. 1. The position vector is represented by OM vector, which is equal to R of t is equal to x of ti plus y of tj. 2. The parametric equations of motion are x, which is equal to x of t, and y, which is equal to y of t. 3. The equation of the trajectory is a time-independent relation between x and y, which allows us to determine its shape. 4. If the equation of the trajectory is in the form of y is equal to ax plus b, then the trajectory is a straight line. If it is y is equal to ax squared plus bx plus c, then the trajectory is a parabola, where the parameters a, b, and c are real numbers. And if it is of the form x minus a squared plus y minus b squared equal to r squared, then the trajectory is a circle of radius r and center a having coordinates a and b. A car is moving from A to B. It may follow many paths. 2 of them are represented by 1 and 2. Regardless of the followed path, the displacement vector, delta r, is the vector oriented from A to B. In the Cartesian system XOY, delta r is equal to r2 vector minus r1 vector, where r2 is the position vector of the final point, which is in this case B, and r1 is the position vector of the initial point, which is in this case A. Let's consider the following example. 2 cars, one in red and the other one in green, are moving on 2 roundabouts, 1 and 2 having the same radii. While the green car moves a complete cycle, the red car moves half the cycle, or half a circle. Now, let's see the difference between the displacement and the distance for each of the cars, red and green. The displacement of the red car is vector AB, and the distance covered by this red car is the perimeter of the circle divided by 2, whereas the displacement of the green car is equal to 0 because the final point is the same as the initial point, and the total distance covered by the green car in this case is 2 pi r. Let's now study the characteristics of the displacement vector. A particle m moves from position m1 to position m2, where r1 is the position vector corresponding to m1, and r2 is the position vector corresponding to m2, and delta r is the displacement vector. Then it is calculated using r2 minus r1, which is equal to om2 minus om1, equal to the vector between the 2 points m1 and m2. What are the characteristics of this vector? First, its origin is the initial position of the particle, which is m1. The direction from m1 to m2 along the line m1, m2. Pay attention here that the direction indicates both direction and line of action. And its magnitude is magnitude of delta r is equal to the distance between m1 and m2, which is radical x squared plus y squared, and note that this is the shortest distance between the points m1 and m2. Pay attention also that the magnitude of the displacement vector is different from the length of the arc m1, m2. Let's have the following example. Let m be a moving particle in the Cartesian system OIJ with the following position vector. R of t is equal to t minus 1i plus t squared j. Determine the position vector at instants t is equal to 1 second and 5 seconds, then deduce the displacement vector. First, to know the position vector at instant t is equal to 1, we have to substitute in the position vector instead of t1, and this will give 0i plus j. R at time t is equal to 5 is equal to 4i plus 25j. Then, to find the displacement vector, we have to apply the rule r2 minus r1. By substitution, delta r will be equal to 4i plus 24j. Let's solve application number 1. Consider a particle that moves along a curvilinear path from point M to N. Part 1. Draw the position vectors r1 which is equal to OM and r2 which is equal to ON. The vector r1 is directed from the point O to point M, and the vector r2 is directed from the point O to the point N. Part 2. Trace the displacement vector delta r which is equal to r2 minus r1. We know previously that this vector is directed from M to N, but how can we prove that? Delta r is equal to r2 minus r1, that means ON minus OM. Minus OM is equal to plus MO. By substitution, this will give MO plus ON, which is equal to MN according to Chasel's rule. Therefore, we have proved that the displacement vector is a vector oriented from M towards N. Part 3. Characterize delta r. Its characteristics are: origin is point M. The direction is from M to N along the line MN. Remember that the direction indicates both direction and line of action. And the magnitude is radical delta x squared plus delta y squared. Let us now learn more about the average velocity vector. The velocity in general is the rate of change of the position vector over time. Let M be a moving particle in the Cartesian system OIJ. This curve represents the trajectory of the particle M, and S1 and S2 are the positions of M1 at T1 and T2 respectively. Let R be the position vector corresponding to time T1 and R2 be the position vector corresponding to T2. Therefore, delta R is equal to R2 minus R1, which is the displacement vector between these 2 points. Delta R is directed from S1 towards S2. Pay attention that when R changes, then the velocity exists. Therefore, we can say that the average velocity vector is given by delta R divided by delta T, which is equal to R2 minus R1 divided by delta T. Its magnitude is the magnitude of delta R divided by delta T. Application number 2. A particle M moves in a Cartesian system x or y. Its position vector is given by R of t is equal to t minus 1i plus t squared j as I units. The position vectors at times t is equal to 1 and t is equal to 5 seconds are given in the following box. The question is, determine the average velocity vector and its magnitude between the 2 instants, t is equal to 1 and t is equal to 5. The average velocity vector is defined by V average is equal to delta r divided by delta t. Then it is equal to 4i plus 24j divided by 5 minus 1, which is equal to 1i plus 6j. Its magnitude is radical 1 squared plus 6 squared, which is equal to 6.08 meter per second. What is the difference between the average speed and the average velocity vector? The average velocity vector is given by delta r divided by delta t, which is equal to r2 minus r1 divided by delta t, whereas the average speed is the distance d covered between these 2 points divided by delta t, which is defined by the length of the arc S1, S2 divided by delta t. But the magnitude of the displacement vector is different from the length of S1, S2. Therefore, we can conclude that the magnitude of the velocity vector is different from the average speed. To understand more the difference between the average speed and the average velocity vector, let's take this example. 2 persons travel 2 roads at the same time. Notice that the first road is curved and the other one is straight. Which person has the greatest average velocity vector? What do you think? The 2 persons travel the same displacement vector during the same time, then both have the same average velocity vector. V average vector is equal to delta r vector divided by delta t, which is equal to V average 1 equal to V average 2. That's because the average velocity vector, like the displacement vector, depends only on the initial and the final points. The average velocity vector of a particle moving between 2 points during the same time delta t is the same whatever the path followed by the particle between these 2 points. But who has the greatest average speed? It is obvious that the curved road has more length, thus the young person should be faster to cover more distance during the same time. Then, the first person covers greater distance during the same time, so he has the highest average speed. Therefore, because the average speed is equal to the real distance divided by delta t, we can say that the average speed of the first person is greater than the average speed of the second person. What are the characteristics of the average velocity vector? What are the characteristics of the average velocity vector? A particle m is moving from m1 to m2, then V average is equal to delta r divided by delta t. Therefore, V average and delta r have the same direction. The characteristics are: origin is undefined. Remember that the direction indicates both direction and line of action. It is along m1, m2 having the same direction as delta r, and its magnitude is the magnitude of delta r divided by delta t. Application number 3. The position vector of a moving object is given by r is equal to OM is equal to 4t plus 1i plus 3t minus 3j. All variables are in SI unit. Question 1. Determine the position vector at instants t1 is equal to 1 second and t2 is equal to 2 seconds. By substitution in the position vector, we will get r1 is equal to 5i plus 0j and r2 is equal to 9i plus 3j. Part 2. Write the parametric equations. They are x is equal to 4t plus 1 and y is equal to 3t minus 3. Part 3. Determine the equation of trajectory. The equation is y is equal to 3 divided by 4x minus 3.75. Part 4. Determine the average velocity vector and its magnitude between t1 and t2. By applying the rule, V average vector is equal to delta r divided by delta t equal to r2 minus r1 divided by t2 minus t1. This will give 4i plus 3j. The magnitude of this vector is radical 4 squared plus 3 squared, which is equal to 5 meters per second. The summary. 1. The displacement vector delta r between t1 and t2 is the vector that connects the initial position with the final position. Delta r is equal to r2 minus r1, and the magnitude of delta r is different from the length of the arc mn. 3. The average velocity vector V average is equal to delta r divided by delta t, which is equal to r2 vector minus r1 vector divided by delta t, and its magnitude is equal to the magnitude of the displacement vector divided by delta t. 4. The average speed V average is equal to the distance covered divided by delta t, which is equal to the length of the arc mn divided by delta t, and pay attention that the magnitude of the average velocity vector is different from the average speed. Thank you for watching.